What is a waveguide? A waveguide is a transmission line that transmits electromagnetic waves in a hollow tube. Initially, J. Thomson and L. Rayleigh et al. Came up with the first proposal for such a system. Since a waveguide is installed within an enclosed tube, the problem of blocking transmission is solved, thus contributing to improved reliability. There is no fear of power spreading in space, thus, there is no transmission loss. Compared to other forms of transmission, better transmission efficiency is offered by a waveguide. For utilizing the features of waveguides, they are widely used as components for high-power transmission, such as for feeding to an antenna for broadcasting and application between a magnetron and a chamber in a microwave oven. Microwave heating applications are not limited to domestic microwave ovens but extend to industrial applications such as food processing and smelting of iron ores. A waveguide is designed to be approximately λ/2 with respect to the wavelength of the electromagnetic wave to be used if the waveguide is circular in diameter. Moreover, in the case of rectangular waveguide, a waveguide is long side dimension. Examples of waveguides. The electromagnetic field is a wave that exhibits sinusoidal variation in time. By solving Maxwell's equations and the Helmholtz equations, the solution of the electromagnetic field propagating in the +z direction can be classified into the following three types. An electromagnetic field can be expressed as a combination of three types of waves. The TEM wave has no electromagnetic field component in the propagation direction. The wave is an entirely transverse electromagnetic wave. A plane wave propagating in space, a flat plate line, and an electromagnetic wave transmitted inside the coaxial line are all TEM waves. A plane wave propagating in an electromagnetic field can be expressed as a combination of three types of waves. Space, a flat plate line, and an electromagnetic wave transmitted inside a coaxial line are TEM waves. The states of the electric and magnetic fields in the xy plane perpendicular to the propagation direction of the TEM wave are the same as those of the electrostatic field and the static magnetic field. Because there is no electrostatic field in the tube surrounded by the conductor wall of the same potential, the TEM wave does not propagate to the waveguide. In order to propagate the TEM wave, it is necessary to use a transmission path comprising two or more insulated conductors. TE and TM waves are generated in the waveguide. The TE wave is also known as the H wave. The Z component of the electric field is an electromagnetic wave with EZ equals 0. The electric field is a transverse wave. The magnetic field is a longitudinal wave. In a rectangular waveguide, electromagnetic waves are transmitted with the TE wave as a basic mode. The TM wave is also known as the E wave. The Z component of the magnetic field is an electromagnetic wave with Hz equals 0. The electric field is the longitudinal and transverse waves, and the magnetic field is the transverse wave. The spherical wave propagating in space is a TM wave. Propagation modes. A cutoff frequency exists in the waveguide, and a frequency lower than the cutoff frequency is in the attenuation mode, evanescent mode, and cannot be transmitted. That is, it functions as a high-pass filter. Conversely, in the TEM wave transmission, the frequency is arbitrary and there is no cutoff frequency.